For our example 3 and 4, we're going to use two Arduinos. One's going to be the master device and the other one's going to be my slave device. Master, it's going to be transmitting data to the slave through I2C, and it will turn on and turn off the built-in LED to show that the message has been received by the master. I have two codes here. You can see here my top one's going to be my slave and the bottom one's going to be my master. So I have two codes here. I'm just going to write here a note, a comment to know that this one's going to be my master code and this one's going to be my slave code. So the first thing that we need to do is to include the wire library. I'm going to start with the slave. So include wire.h, and let's define the address. It's gonna be 4. Remember, we can use any number between 0 and 127. I'm just using 4 because it's my favorite number. And the built-in LED, it's pin 13. So LED is pin 13. We're gonna use wire begin, and since we're in slave mode, we need to write the address. So wire begin address, which is number 4 in this case, and let's initialize LED. So pin mode LED is now put, and let's start with LED turn on. So detail write my LED as high. Okay. Now, something that we need to do that's important, it's that we need to use an event. So it's this line right here that's gonna help us on the slave to jump from the loop to that event to save the data that we are receiving from the master. So let's just make a variable called Rx. You can call it whatever you want. I'm just calling it Rx. I'm gonna make it equal to 0. So here I'm gonna just put wire on receive, and you need to write the name of the event. So I'm just gonna call it receive event. That name needs to match here below, so it's void receive event, and we're gonna use an integer called how many. It's the number of bits that you're receiving, but you won't use it, so don't worry about it. Just write it down in your code, but you won't use it. Now we're gonna use a while one. While 0, not a while one, but a while loop. While 0 is less than wire available. So we're just checking if we're receiving data through I2C or while we're receiving data. What we're gonna do is we're gonna make our Rx equal to that data that it's been received. Wire.read. So we're gonna save whatever data we receive into Rx. So we're gonna be playing here in the loop. Here's the slave just looping around. When we receive something, it'll jump to receive event. It will check that while you're getting data, that data will be saved into Rx. So it's gonna be overwritten with the data that we're receiving. So if Rx is greater than 0, I start with Rx equal to 0. So if I receive something, that's gonna be greater than 0. As soon as I receive something, let's turn off our LED. So it's digital right LED as low. Let's program it for this one in the top. So let's see if it flashes that one. Here you go. It's flashed, and it should start with the LED turn on. Pin 13, address. Okay, let me reset it. There you go. Oh, it's because, oh, okay. Let's program the master. It's receiving data from, I was testing it before recording the video. So I'm just gonna program the master with nothing. There you go. Now let's reset the slave. And it should have the LED on. Okay, now the slave, it's turned on, but it's not turning off because it hasn't received anything from the master so far. Now we need to program our master to send that data. It can be any data. Doesn't need to be anything specific. As long as we receive something, that will shut down the LED. So in my master, I need to include the wire library. Same thing. Include wire.h. I'm gonna define the slave address. So my slave 1, it's gonna be 4. And let's initialize it. So it's gonna be wire.begin. We don't have to put anything here because we want to go in master mode. So remember, when we go master device, we don't write anything inside of it. Now we're gonna transmit data. So let's go here and write wire begin transmission slave 1. So we're gonna start communicating with the slave address, which is 4. We're gonna write, it can be any number between 0 and 100 and 255, sorry. But I'm just gonna send the 1. It can be char, it can be integer, it doesn't matter. And let's do wire and transmission. So it's gonna be blasting it, but I'm gonna add a delay of 1 second just to not blast it and send that 1 every second. So that one goes for the master. We have the slave already just waiting for data. We're gonna program the master to be sending a number 1 every 1 second. See if it flashes. There you go. And it's shutting down because we're sending a 1. Now this can be any number. It doesn't need to be a 1. Let's try 30. I'm gonna program the master again. So it's flashing the LED, it's on, the master sends a 30, and now it's shutting down. So we know that it's working. Now let's make something more interesting. If my Rx is equal to 0, let's turn off the LED. And if my Rx is equal to 1, let's turn it in high. So let's first send 1, and then we're gonna do the same thing, but now we're gonna send a 0. So it's gonna be 1 0 1 0, and now we should see the LED turning on and off, on and off. So let me see if I flash the master. That's the master. And now let's flash the slave. There you go. Good. So now it's turning on and turning off, turning on and turning off. And that's because the master is sending a 1, then a 0, a 1 and a 0, and the slave, it's programmed to receive a 1 to turn on and a 0 to turn off. Right now I'm using integer numbers, but again, we can use ASCII numbers. It will be the same effect. I mean, right now I'm just gonna program the master. They will differ because it's not the same thing, an ASCII one as an integer one. So let's try this first. It won't change anything. That will not, the slave will not be able to process the data because now the master is sending it in ASCII format. So as you can see, the slave is not blinking because it's expecting to receive the data in integer format. But if I change this one to ASCII format, it should work now. So let's blink it. There you go. So that's how lab example 3 and 4 works.